Okay, Algebra 1 class, welcome to day 2 of online learning. I'm trying something a little bit different today. I've got the notes for you. I'm going to walk you through them, and then I'm going to print them out and put them online for you. And so you'll have a copy of this to look at, maybe while you watch the video, I'm not sure. But this is, we're given the equation y equals x plus 3 squared plus 1. And how can we go from that to this guy, y equals x squared plus 6x plus 10? So all we have to do is we have to take this piece where it's squared, and we're going to multiply that by itself. X plus 3 times x plus 3 plus 1. Then I don't know if you remember, first times first, outer times outer, inner times inner, and last times last. We're just distributing these together. Or we could use the box method as well, where with the box method, we had this guy where we said, look, x plus 3 times x plus 3, x plus 3. And we multiplied x times x to get x squared, 3 times x to get 3x, then x times 3x, 3 to get another 3x, and then 3 times 3 gives us 9. We have to combine the like terms in the middle. So this is going to give us x squared plus 3x plus 3x is 6x plus 9. And that's how we get from this to here. But oh, I almost forgot I had to add my 1 onto this. So this gives me x squared plus 6x plus 10, which is exactly what we were trying to get up here. Okay, hope that makes sense. Going to be putting that on the blog for you so you can look at it. The next problem we have is, what about y equals 3 times x plus 2 squared plus 3? And then we're going to 3x squared plus 12x plus 15. So we're basically turning what we're doing is turning a vertex form equation into a standard form equation. And the secret is doing this part first. Then we'll multiply by 3, then we'll add 3. So this can be rewritten as 3 times x plus 2 times x plus 2, because anything squared is just itself times itself, plus 3. And again, we're doing the same thing where we do first times first. So x times x is going to give us x squared. And then x times 2 is going to give us 2x. And then that's first times first, outside times outside. Inside times inside is another 2x, and last times last, 2 times 2 is 4. And we have plus 3 on the outside here. So this has to be done first, then the 3 has to be distributed into this equation. 3 times x squared is 3x squared. 3 times 2x is 6x. 3 times another 2x is another 6x. And then 3 times 4 is 12. And then I have to remember to add on my 3. Now I'll just combine my like terms inside here, and I'm going to get 3x squared plus 6x plus 6x is 12x plus 12 plus 13 is 15. And now I have this, which equals that. It's the same thing. Okay. I'm going to try to write a little neater from here on out because my handwriting this morning is pretty terrible. Now let's get to what we really need to be looking at here. And what we're looking at is the standard form of a quadratic function. We've seen this over and over where a quadratic function in standard form is some number a times x squared plus some number b times x plus c. And A determines how the graph opens. Remember, if A is positive, the graph opens up. And if A is negative, the graph opens down, okay? And also 0, C is always going to be the y-intercept. And we haven't really discussed that much. Let me get something to put my paper on top of to bring it a little closer up to the camera here. So 0C is the y-intercept. We need to make sure we make note of that because we're going to need the y-intercept as we go forward and graph these things. We need to find the vertex. We need to find the vertex. Graphing in standard form is similar to graphing in vertex form, but the way we find our vertex, is different. We use a special formula to find the x-coordinate of our vertex and substitute that value in our equation to determine the y-coordinate of our vertex. That formula is right here. X equals negative b over 2a. Well, where's that b and 2a coming from? Remember, it's coming from the standard form. Y equals some a times x squared plus some b times x plus some c. This a and b are coming from our standard form, okay? So for example, here's an equation. How would we find our vertex? Well, a in this equation is just 1 because there's no coefficient out here in front of the x. We can put a 1. So a equals 1, b would equal 2, and c would equal 7. Okay, we got those right in the equation. So to find our vertex, we first solve for x. X in this case would be negative b over 2 times a, which equals negative b is going to be negative 2 over 2 times 1. Negative 2 over 2, negative 2 over 2 equals negative 1. So our x value for our vertex, that's our x value. Our x value equals 1. And we take that x value and we just simply plug it back into this equation to solve for y. So we had y equals x squared plus 2x plus 7. We're going to take our negative 1 and put it in here. Y equals negative 1 squared plus 2 times negative 1 plus 7. Okay. And then we're just going to continue to work this down. Negative 1 times negative 1 is 1, plus 2 times negative 1 is negative 2, plus 7. 1 plus negative 2 would be negative 1, and negative 1 plus 7 would be positive 6. So y equals 6, x equals negative 1. Our vertex would be at negative 1, 6. Negative 1, 6. That's our vertex. That's our vertex. Okay. Next, practice with finding the vertex. Find the vertex for each of the following quadratics and determine whether the graph opens up or down and find the y-intercept. We can do that. We can do that. In example 1, we're going to solve it the same way we did here before on the previous page. We're going to use the formula to solve for x. Once we solve for x, we're going to plug x in to the original equation. We're plugging x into here to solve down for y. So we have our x, we have our y, and together they make our vertex. I'm not going to spend video time explaining and solving through all of these. I'm just going to solve them and post the final notes on the graph. Okay, same thing on this page. We're going to do the same thing, and I'll have these notes on the graph for you. Now let's go forward to graphing, steps for graphing in standard form. Let me lay the paper back down so you can see the whole thing. Step 1, we have to find the vertex, which I just showed you an example of. You know, we use this formula to find the vertex. Remember, this a and b is coming from the standard form. And we find our x-coordinate, we substitute x back into our equation, and then we solve for our y-coordinate of our vertex. Okay? Now, after you get your vertex, you have to use your vertex as the center of a table and determine 2 values to the left and to the right of your x-coordinate to substitute for those x values back into the equation to determine the y values. Very similar to what we did yesterday. Actually, it's exactly like what we did yesterday after we had the vertex form of the equation. Plot our points and connect them from left to right. Now, the video that I've posted on today's lesson for you is really, really good at this, and he does a little trick there to get extra points when you're graphing. But I'm going to go ahead and show you this one. And after I show you this one, I'll go ahead and work the rest of the notes and put them on today's lesson for you so that you can work them. I highly recommend today's video, this video, but also the additional video, okay? So the first thing I'm gonna do is I'm gonna find my vertex. The way I find my vertex, if you remember, we're using that formula, negative b over 2a, negative b over 2a. First, I need to identify my a and b. Well, in this equation, my a is going to be a 1 because there's no coefficient there. So a equals 1. And my b is going to be negative 2. See it here? B equals negative 2. Now, I put that into my formula to get x. Once I get x, I have to put x back into this equation to solve for y. Okay, so let's use this to find the x value of our vertex. If I'm taking negative b, I'm getting a negative 2, okay? A negative 2 over 2 times a. What is a? 1, 2 times 1. So this is my formula. I'm solving for my vertex. Let's go ahead and work that down. A negative 2 is a positive 2, because this is the same thing as like maybe thinking of it as a negative 1 times negative 2. All the time I always say, many times over, when you have minus a negative, make it into a big positive. So this is going to give me 2 over 2 times 1 is 2, and then 2 over 2 just simply equals 1. So my x value for my vertex down here is a 1, Now that I have my x value, I plug this x back into this equation and solve for y. I want to know, what is y equal to when x equals 1? So let's do that. Y equals 1 times 1 squared minus 2 times 1 minus 1. I plugged my 1 in for my x everywhere in here, and I'm solving for y. Y equals 1 times 1 is 1. And then that 1 times another 1 is just 1 again, minus 2 times 1 is 2, minus this 1 out here. Y equals 1 minus 2 would be negative 1. Negative 1 minus 1 would be negative 2. So here's my vertex. When I use the x coordinate formula to solve for my x value, I plugged in my value for a and b here. I got my x value. This 1 equals x, okay? Then I took my x value at a 1 and plugged it back into the equation and solved for y. So in other words, when x equals 1, y equals negative 2. Let's put that right here, 1 and negative 2. 1 and negative 2. That's our vertex. We can come on over here if we want to, and we can graph our vertex, 1, negative 2. So we know from this point the graph is going to go up because a is positive. So it's going to go up, but we don't know what other points we need yet. Let's take these x values, plug them into the equation, and see what our resulting y is. So here, I'll work one more for you. I have y, I'm going to rewrite the original equation down here, x squared minus 2x minus 1. So I'm going to plug 0 in for x. 0 in for x, y equals 0 squared minus 2 times 0 minus 1. So when x is equal to 0, I'm getting this way. 0 times 0 is 0, minus 2 times 0 is 0. 0 minus 1 is negative 1. So this tells us that when x equals 0, y equals negative 1. Negative 1. We can go ahead and plot that over here at the point 0, -1. Now we know this is a parabola. We know this is our axis of symmetry. In other words, because that's where our vertex sits, we know it's going to go up. And we almost don't even have to work this one here. We know it's got to also be a -1 because this is symmetrical. It's going to be the same on both sides. And I'll just quickly check it. If I plug a 2 in for x, that would be 2 times 2 is 4, minus 2 times 2 is 4, so 4 minus 4 is 0. 0 minus 1 would be -1. So it does check out. It does check out. Let's go ahead and work our 3. If I plug a 3 in for x, it would be 3 times 3 is 9. 9 minus 2 times 3 is 6. 9 minus 6 is 3. And then 3 minus 1 would be 2. Over here, it's going to be symmetrical, so I can just go ahead and write a 2 in there. So at the point x equals 3, y equals 2, I would be here. And x equals -1, y is going to equal 2, I would be here. And so I can go ahead and plot my parabola or draw my parabola. It's going to be something like this, guys. Okay. And that is how you graph a parabola using the formula to find your x value. You use the formula to find your x value. After you find your x value, you plug that x value in to the original equation to find your y. That's your vertex. That's your center value. Then you pick some values on either side, plug those in, work down for your y's, plot your graph, you're good to go. I'm not going to take up any more video time to show you these other examples. You should easily be able to work through those. There's nothing really tricky there at all. And then I've included something for you while you're at home if you get a little bored. If you have a graphing calculator, you can play with that to have the graphing calculator plot parabolas for you. Really, really cool stuff. Now remember, I've heard that we're probably not going to have an EOC this semester, but if we did, we could use Desmos to plot these parabolas for us. So if you want to go on Desmos and you can just type this in just like that and look at the parabola, maybe put some numbers in here and things to see how the parabola changes shape as you do some transformations. Good luck with that. And if you have any questions as normal, just give me an email or hit me up on Remind and I'll be glad to help you. I also recommend the other video.